everyone, I'm Andy from Adaptronic, and in this video I'm going to talk about different idle control actuators and how to wire them up and set up the outputs in the ECU. Idle control is the function where a lot of people get fairly confused, and that's because it's actually very complex to set it up correctly. But when it is working right, it makes a big difference to the drivability of a car, so it's worthwhile spending some time on. In this video I'll just talk about the different types of idle control actuators and how to wire them, and then in another video I'll talk about how to set it up properly in the ECU. The simplest idle control actuator is actually a 2-wire solenoid. A lot of people call these an idle motor, but it's not actually a motor because there's no rotating parts, it's actually just a solenoid valve. A really good example is the Ford one, which is one of these, and it's a good example because you can see the parts inside. So in this case the air flows in through the bottom here and comes out here into the engine. The engine vacuum, which is on that port, draws this plunger here closed. This solenoid at the bottom pulls this plunger open to let more air go through. So this valve has a plug with 2 terminals on it. One needs to connect to 12 volts, the other needs to connect to an auxiliary output on the ECU that can be driven as a PWM output. So on the select ECUs, that's aux output 1, 2 or 3. There's another version of this valve which has 2 circular ports. So you can just tap them and then fit threaded fittings and then connect air hoses to them for an aftermarket installation. Most Nissan engines use the 2-wire solenoids, so that includes the SR, CA, RB and VG engines. But they also normally have a wax pellet which lets more air into the engine when the engine's cold. For this reason you see coolant hoses connected up to the idle valve. So this means that you don't need any additional idle effort when the engine's cold on these engines. You just need to use the idle valve to compensate for electrical loads and power steering loads and that sort of thing. In fact, Nissan engines normally have a separate idle valve which is connected in parallel with the air conditioner clutch, so that more air flows when the air conditioner's on as well. This is normally called an FICD or fast idle control device. Nissan love their acronyms, I don't know why. Lots of Mazda engines also use the 2-wire solenoid valve. So this includes the B series engines like the B5, the B6 and the BP, as well as the 13B engines. The Mazda ones also normally have a wax pellet so that it emits more air when the engine's cold. And again, you have coolant hoses going up to the throttle body. However, there's not normally a separate idle valve for the air conditioner. So that means that the idle valve on the Mazdas normally has a more control authority than on the Nissan engines. So if you turn it on fully, you'll get a bigger increase in the RPM compared to on a Nissan engine. Now also, I don't know how they do it, but on the Mazda valves, if you don't drive the valve at all, it operates at about half its normal flow. Whereas on the Nissan, if you don't drive at all, it doesn't flow at all. So to actually get it in the middle of its range, you normally have to drive the valve with about 65% duty cycle, or more like about 50% duty cycle if you've got a recirculating diode. And that's your base value, and you need to adjust it up or down from there, rather than adjusting it up from 0 like on the Nissan engines. It also means that because 0% duty cycle actually flows more than, say, 30% duty cycle, you need to set a minimum value on the ECU for the idle duty cycle. Otherwise it gets very confusing. You can also find these 2 idle control valves on the Honda engines. So to use one of these valves with a select ECU, you need to connect one terminal of the valve to 12 volts, and the other terminal connects back to a pulse width modulated auxiliary output on the ECU, which is aux output 1, 2 or 3. Some of the valves are actually polarity sensitive, so if you don't know how to work that out using a multimeter and a resistor and a power supply, then you should consult the factory wiring diagram for the car that had that valve. Then for that output in the ECU, you need to select it as idle control and enable PWM. You also need to set the frequency. Now this can be a bit of an experimental process. Lower frequencies give you better control usually, but higher frequencies are better for reducing the buzzing sound. So because the idle valve is moving very quickly back and forth, even by a small amount, that sets up a pressure wave in the intake system. So you can actually hear a buzzing at the PWM frequency through the intake. So the way to reduce that buzzing is step up to a higher frequency. The highest I've ever seen that we need is on the Mazda MX-5 and Miata NBs. They need about 500 Hz. Most other valves can handle lower frequencies than that. The next type of idle valve that we'll talk about is the 3-wire, which is also called a rotary motor. You find them on some Subaru engines, a lot of the European engines because it's a Bosch component, and also the 4-cylinder Toyota engines like the 4AG, 3SG and so on. We've also seen them on some of the Korean engines like the Hyundai and the Kia because they use Bosch components generally. On these, the middle pin has to connect to a 12-volt ignition switch supply, and then each of the other two outside pins connects to aux outputs 3 and 4 on the ECU. Generally, you'd try to connect aux output 3 to the pin that you pull low to increase the idle air, and aux output 4 goes to the pin that you pull low to decrease the idle air. Then set up auxiliary output 3 as an idle control pulse width modulated output, just as a solenoid valve. Normally the frequency has to be around 250 Hz, and then set up aux output 4 as being the inverse of aux output 3. Once you've got it running, you can see if the higher idle effort corresponds to a higher RPM, and if it's not, then just invert aux output 3. The next common one amongst our customers is the 6-wire idle stepper. You find these on Mitsubishi engines, 6 and 8 cylinder Toyota engines, and some Subarus. The stepper motor has 2 coils internally and each one has a center tap. So on the connector there will be 2 rows of 3 pins. The middle pin on each row needs to connect to ignition switched 12-volt positive, and if you have enough outputs on the ECU, you can connect each of those 4 remaining pins to auxiliary outputs on the ECU and select them as shown. Or if you don't have enough outputs to do that, you can connect them to a stepper motor controller board and then connect that to the ECU and set it up as shown here. Then you need to set the step duration. 11 milliseconds is what most idle motors use. You also need to set the maximum effort being the number of steps of the motor. Toyota ones tend to be 125 steps and the Mitsubishis are 120. Note that the ECU will open the stepper motor through its complete range of travel when the ignition is first turned on. This is so that the ECU knows the home position of the stepper motor, and it also gives the engine the most air so it starts most easily. But it does mean that when you first turn the ECU on, you'll hear the motor whir or rattle even. Also, when the idle effort is at its maximum, the ECU will continue to pulse the coil every 4 seconds so that it knows that it's staying there. So don't be surprised if you hear that click every 4 seconds with the ignition on but the engine not running. Once you get the engine running, you can again confirm that the higher number means the higher idle RPM. You can also do that by removing the idle motor from the engine, turning the ignition on and watching the plunger. If the plunger moves all the way in, that means that it's connected the right way. If it moves all the way out, then you need to reverse it. The easiest way to reverse it is just find either the output that's marked as idle hold 2 and invert that, or if you're using 4 wires to go to the idle motor from the ECU, then invert both the ones marked idle hold 2 and idle hold 3. The last type I'll describe is called the 4-wire GM stepper motor because you find it on General Motors engines. Internally, this is basically the same as a 6-wire stepper motor, except that the center taps do not appear, which means that to drive the coil in each polarity, you need to be able to drive each wire high or low. The auxiliary outputs from the ECU only pull low, so you need to use the stepper motor driver board to be able to drive them high. So that needs to be wired up as shown here. The GM motors have 250 steps and need a step period of 5 milliseconds. Again, if it's the wrong way around, so if the plunger extends when you turn the ignition on instead of retracting, then you just need to invert the idle hold 2 output. Okay, that's it for the hardware and the auxiliary output settings for the idle control valves. In the next video, I'll explain how to set up the idle settings in the ECU.